Logarithms. Logarithms are mathematical elements characterized by the initials log or ln. In this example, the base is 3 and the argument is 27. Unlike in roots or pairs, there are no particular graphic elements to mark the boundary of the argument of a logarithm. The only one is the base, which appears on the right in the form of subscript in the logarithm. In the inscription in black, the argument is in brackets, so in lambda we don't need to open and close the argument. As a matter of fact, it appears as in the writing in black with the bracket. As an example, if I write logarithm of x and then plus 2, the logarithm is obviously referred only to x. If, on the other hand, I want the logarithm of x plus 2, I need to write brackets. Therefore, in lambda, we act exactly as in any normal writing. Yet, we need, and this is why the logarithm is red, an opening and a closure only referred to the base. So we need a bit of a structure. Yet, to simplify, cases such as, for example, the natural logarithm, that is base e, and the decimal logarithm, that is base 10, in which the base is implied, we could obviously write it exactly as it is. So, we could simply write ln or log, possibly with a capital letter, like this, and the characters we digit will describe the mathematical symbol. Moreover, when solving these expressions, we don't generally need to create special tricks or take specific teaching actions. The process is quite simple. Anyway, let's explain how to define a logarithm. A generic logarithm, the first one I wrote, is done this way. You digit log, you specify the base, which can be either a number or a letter, or even a short expression, for example, a plus 1. At this point, we introduce a closure through Ctrl K, because we need to say that the base is finished. And then we can write the argument. If it is a number, it gets written simply, whereas if it is an expression, we'll need to use brackets. Then there is the natural logarithm, ln, as you can see here. You just need to write ln and the sign appears in green. This means that it is a single element, and then any argument is to be written either in brackets or simply with a number. Then there is the decimal logarithm to base 10, and in this case too, since we do not need to specify the base, we can simply write log. But as we see, it needs a capital letter. It gets written in black, whereas this other sign is written in green. This green one is understood by the system as a natural logarithm, and in fact, by moving with the arrow keys, we do not move letter by letter, but log is understood as a single element. In order to do this, there is a shortcut key, which can be found, for example, by digiting F5. So let's look for logarithm, and it is the first one, decimal logarithm, and it gets written with Ctrl M Shift L with a capital L. Therefore, Ctrl M and then Shift L, and we'll introduce the term logarithm, which is then recognized as an element. And then we can digit the argument. If the combination Ctrl M Shift L is a bit cumbersome, we can change it from profile. In this case, we can change the associated key. For example, we could write the decimal logarithm directly through Ctrl L, with no need to use the default one. The last thing to point out is that we need to pay attention to nested expressions. That is, if I want to say logarithm of x squared, the power is to be inserted after x. Whereas, if I want to write square logarithm of x, this is not good, so I'll delete the previous line with Ctrl D. So, if I want square logarithm of x, pay attention to write it correctly, maybe even with brackets. Let's double check with F4. And here they are, logarithm of squared x and squared logarithm of x. They get actually understood in the two ways we wrote them.